Hi guys, I'm AnalysisWX.com's weather analyst Andrew Fleck, just here for a Tuesday sit-down discussion. And what we're mostly going to talk about tonight is going to be that storm late week on Tuesday, that Black Friday storm as some are calling it. And those for around the west and the central United States, this is the type of storm in the east where you got to kind of look at it and say, look, as early as it is, where the storms form around those areas, it's sometimes rather a big deal. But if there was a snowstorm in the central United States or western United States, it would still be a major deal as well. But the just big reason here is it's an earlier time period where you're starting to have a coastal line up along the eastern seaboard, and the possibilities of a snowstorm rely about 50-50 right now. And that's what we're going to kind of talk about just on this video discussion. But before I go into just one particular region, I'm going to go off and still analyze the radar and look at some temperatures to give you throughout the United States. So looking at here on the radar, we can see that you have two energy pieces, and this actually comes down with the trough. Last night I showed the vorticity maps. I showed you how there was one energy piece here and there was another one up here. And the big question was, how strong was this one going to be? Because depending on how strong this piece here was going to be, depended on how amplified it made this primary trough from this energy piece 1 to be. And if this were to connect and pretty much amplify this number 1 too much, you'd have a trough extending like this, which the models on Monday pretty much were in heavily agreement on. Now, if this primary energy up here doesn't exactly amplify this primary number 1 here as much as it could, and like today's models have had, well, then what's going to happen is you're going to have this trough dig down, okay, off the coast. This energy piece here feeds up along the jet, and you have some cold air able to actually move just almost off the coast, and some of that energy is able to kind of backlash its way into some of the coastal and inland regions, and you could get yourself a snowstorm. So what I talked about on the vorticity and what was just a model away is now looking at reality. You have piece number 1 and piece number 2. So there you kind of have what we're looking at currently and what is starting to make a little more sense. So looking at mainly around the United States though, and looking into more of this piece 1 and piece 2, we're going to see that in piece 1 or energy source 1 that there's some convective rain occurring. We have some probably real heavy convective wind-driven rains right now across Iowa, Illinois, Wisconsin, Indiana especially, and that's going to probably leave the potential for maybe 1 to 2 inches wherever you fall into that location for some rain. Would not be surprised if there are some isolated amounts of just a little more. I would pretty much keep an eye on that, and a good eye on it to be exact. And up here in this energy here, this energy piece 2, this is that piece that's going to be a little more colder. It's more in the colder air, and that's going to be given a mix, more snow and mix than rain. So pretty much it's a good visual of what you're seeing right now and what we looked at on the models a few nights ago. Now looking at the temperatures, we can see that it does make sense because we do have that system across Illinois, and we have that warmer air, okay, and remember low pressures have that cyclonic rotation and motion to them, so it's bringing up warmer air to the east of the low pressure and digging into the storm, and that's where you're seeing more of a warmer temperature-wise across the eastern path of this storm. And then you have another storm up here around the Dakotas, and that's where you're seeing more of snow and ice and less of rain, and that's why it's a little colder around some of these spots in here. So given now, as we move on, after looking and giving you kind of the observation of the United States, we're now going to go and explain what this energy piece 1 and 2 is going to do as we move on in the next day or so as it leads to Friday. And what we're first going to go and do, okay, is show you the map, okay, of the GFS across the Mid-Atlantic northeastern regions, even Ohio Valley. And what I'm going to show you here is pretty much the precipitational map. A lot of people, go and they look at the 850 millibar, and the 850 millibar is not your mid-levels, not your upper level, but I always call it between the mid-levels and ground, okay, levels. and that's considered your surface levels. And a lot of folks say that when you look at a weather model, okay, and it has your 850 all the way out here off the coast, and you're in precip looking at a map model without looking at a precip type model, it pretty much is a given that we're getting snow. And there's a big problem with that a lot of folks don't understand. You see, 850 is not mid-level. There's not room from 850 to the surface like there is from 500 to the surface. If it were to be cold enough, okay, on the 500, from surface to 500, it's all snow. But 500 millibar during this event is going to be way warmer, and it's going to support rain. But if you were to go to the 850, okay, you would be talking about 850 from 850 to surface not being exactly as cold, and maybe if cold enough, not enough time for it to freeze from 500 millibar mid-levels to quickly freezing to 850 and leading to snow on the surface. So a lot of folks say, oh, the 850's pushed by us, that means we're getting snow. Doesn't exactly mean that, and that's what I'm going to kind of prove tonight. In this area here, you can see some snow, okay, finally on the preset map. And then you kind of say to yourself, well, that's pretty cool, you know, Maryland, West Virginia, Western PA, they might be having some snow based on this latest 18Z run. But I don't understand how in the world the 850 has pretty much its line pushed out off the coast and it still shows rain in here. Well, the reason for that is there's not cold enough temps. Maybe you just have cold enough temps on the 850, and when you have 850 so close to surface, it can't support or cool down quick enough to produce snow. So instead it produces a cold rain. And I'm going to prove that on this next imagery. Again, you see here how you have a colder spot here, and this is the area that the imagery that I just showed you had snow. But then again, you see here in this area here, it's all rain. And that is because you have deeper and colder air in this area by maybe another 5 to 10 degrees, and only here you're just on the edge of freezing. And when you're on the edge of freezing from it raining in the mid-levels to on the edge of it freezing on the surface levels, it's very hard from it going from maybe 40 degrees to 32 degrees. It's not exactly going to be freezing quick enough and that dense enough to just produce quick flakes to be falling and sticking. And it's going to be very hard for that to occur for folks that, you know, are in the 850 or just in the zero line of the 850. But if you're really in the 850 and really past the zero line, you're looking at snow. You're looking at snow whether it's elevation or not. But like I keep saying, if you're on the verge here, you know, the chances are probably maybe flakes mixing in rather than a large amount of snow occurring. Again, look what I just observated to you. Colder air by another 5 to 10 degrees than any of these areas up here. Okay, and then as we go back, it shows it. Okay, so that means that the 850s have to be colder than just over you or just passing you for it to really snow. So as we go into the next imagery here, we're going to show you that now, it looks like now really the whole area, Pennsylvania, New York, New Jersey, Delaware, Maryland, they're all past the 850 line. So this means that the whole area here is getting snow if there's precipitation. Well, not so fast. If we go forward once, we can show you that it still pretty much shows rain. And that again is because of 850 to surface, there's not too much of a distance in the atmosphere. The only way I see that happening is if you're up in the higher elevations where the 850, okay, is way up north, way on a hill where it's colder and significantly colder like we were talking about down here in Maryland and West Virginia, okay, then that is the way you get snow. So it's very hard if you only have the 850 by a few degrees passing over you to get snow. If you're in the higher elevations or you're in a colder 850 pocket, that's where you're going to get your snow. But again, people have to realize that, you know, 850 to surface is very close together. And if you're warm in the mid-levels, you know, you're going to have a very, very cold 850. If not, you're not getting the storm or you're not getting the snow. But you can have flakes mix in. But you need to have a colder, an extremely colder 850 if you don't have a cold 500. So that is your observation for tonight, and I may have some more updates later tonight, so look into that possible. And feel free to chat on the forums again, guys. I want to keep talking about that more and more to get more people really talking and chatting. So have a good night, and maybe I'll talk to you guys in a little bit.